my dear students. Let's start the session.
Clear? So case 1, write down simple pendulum, angular SHM, case 1. Case 1. Here, simple pendulum oscillating in the water medium, liquid medium. Here you can take simple pendulum is oscillating in liquid medium. Here to here, entire part is density of the fluid. Density of the fluid. Density of the fluid. We need to disturb the system about this point. We need to disturb the system about this point. This is your angular disturbance. Angular disturbance. Okay, so weight always at vertically downward direction. Weight always at vertically downward direction. Buoyant force always at vertically upward direction. Buoyant force. Buoyant force equal to how much? Density of the fluid into volume of the fluid displaced into G. For completely submerged body, volume of the fluid displaced equal to volume of the body. Volume of the fluid displaced equal to volume of the body. See here. What is the here weight acting vertically downward direction? Then inertia torque always at opposite to the direction of angular motion. I naught theta double dot. I naught theta double dot. So we need to convert like this. We need to convert. Draw free body diagram separately. Draw free body diagram separately. Here to here. This could be here mg. Total net force is acting downward direction. Mg minus buoyant force. Mg minus buoyant force is acting downward direction. Mg minus buoyant force. Here to here, this would be theta. Here how much is that? How much you be getting? Mg minus buoyant force into cos theta. Mg minus buoyant force into sin theta. Angular disturbance about point O. So inertia torque will be acting opposite to the direction. So inertia torque equal to how much? Inertia torque about point O. IO theta double dot. IO theta double dot. Apply moment about O. How much is obtained? Apply moment about O. N. This is the length of the string. M is the mass of the bob. Sigma MO equal to 0. Inertia torque. Inertia torque about point O plus. How much is obtained? Mg minus buoyant force into sin theta. Sin theta into length is the moment about this disturbing point. So then what you will get? Inertia torque. This is the mass moment of inertia plus mg minus buoyant force. Density of the fluid into volume of the fluid displaced. That equal to V into L into theta equal to 0. Clear? So the name right chapandi. I over name right chapandi. ML square and Raicha. I over is nothing but ML square theta double dot plus. So ikkada mg బయటకి తీస్తే ఏమొస్తుంది చెప్పు 1 minus density of the fluid into volume of the fluid by m into g, that is m only. L into theta equal to 0. Clear? Then theta double dot plus m gets cancelled out. L will go. Then G by L into 1 minus density of the fluid into volume by density of the body into volume. Theta equal to 0. then theta double dot plus G by L into 1 minus density of the fluid by density of the body into theta equal to 0. So from here we can apply, we can compare with the angular SHM. Definition of angular SHM. Theta double dot plus omega n square theta equal to 0. Now omega n square can be written as, from here omega n square can be written as, omega n square can be written as G by L into 1 minus density of the fluid by density of the body. Here omega n square equal to G effective by L. G effective by L. From here omega n equal to square root of G effective by L. Then 2 pi by t, we can write 2 pi by t equal to square root of G effective by L. So t equal to how much? 2 pi square root of L by G effective. Here G effective is how much here? What is the G effective here? G effective here, G into 1 minus density of the fluid by density of the body. 1 minus density of the fluid by density of the body. This is the regular procedure to determine time period of oscillation when the simple pendulum is in the fluid. అర్థమైతుందా? So మామూలుగా what is the short trick? What is the short trick? Completed. అది ఆన్ చేసాం కదా. బ్రైట్నెస్ పెంచాం కదా. ఓకే కంప్లీటెడ్. వాట్ ఈస్ ద షార్ట్ ట్రిక్? ఇది డైరెక్ట్ గా ఆన్సర్ చేయొచ్చు. 3 మెథడ్స్ లో సాల్వ్ చేయొచ్చు దీన్ని. దిస్ ఈజ్ మెథడ్ 1. వి డిస్కస్డ్ మెథడ్ 1. మెథడ్ 1. మెథడ్ 2. నెక్స్ట్ మెథడ్ 2 షార్ట్ ట్రిక్. హౌ టు అప్లై షార్ట్ ట్రిక్? Completed. This part completed. How to calculate G effective for 10 cases? Total 10 to 15 cases will come. Completed?
No, sir.
Connect. Method 2. How to write G effective directly? How to write G effective directly? Focus here. Method 2. Method 2 for the same question. Case 1. See this. What is the question here? This could be it is oscillating in the medium of density of the fluid. So now tell me, here to here, this is young. Understood? So first, weight always at vertically downward direction. Weight always at vertically downward direction. Buoyant force always at vertically upward direction. Okay na? In the direction of mg, you can take the net force mg minus buoyant force. mg minus buoyant force. This is balanced by mg effective. This is the net force acting. Net force F net. Net force acting on the valve is balanced by mg effective in opposite direction, mg effective in opposite direction. These two are balanced. First calculate the F net. F net is balanced by mg effective, exactly opposite direction. We can represent mg effective. Straight away tell me, what is mg effective here? mg effective here, tell me. mg minus buoyant force. mg minus buoyant force. That equal to how much? mg minus density of the fluid into volume of the fluid into g. Then m into g minus what? Completely submerged body. Volume of the fluid displaced. For completely submerged body, volume of the body, density of the fluid into volume of the body into g. Take mg out. Take mg out. 1 minus density of the fluid into v by vg by mg. Here it is how much? mg effective. mg effective. mm gets cancelled out. g effective. G into 1 minus density of the fluid into V by density of the bob into V. Density of the bob into V. Finally, G effective can be written as G into 1 minus density of the fluid by density of the body. Density of the fluid by density of the body. What is the time period of oscillation? 2 pi square root of L by G effective. L by G effective. What is G effective here? T equal to, you can write time period of oscillation in this particular case. 2 pi square root of L by G effective can be written as G into 1 minus density of the fluid by density of the body. Okay, now this is method 2. Now coming to method 3. How to get G effective by using method 3? Completed. This part done. Method 3. Apparent weight calculations. When the fluid is in first flight mode avi. Okay. First case is avunandi. Phone వదిలేసేయండి. First focus here. అర్థమైందా? ఫోన్ వచ్చినా పెద్ద ఫరక్ లేదు. సైలెంట్ లోనే ఉంది. క్లియర్ అయిపోయిందా ఇది? Completed. Next right now, method 4. Method 3. So how to answer this question? When the body is in fluid environment, what is the weight of the body? Weight of the bob in the fluid. Weight of the bob in the fluid environment. When it is in the fluid, it is in the fluid. Clear? So you need to take apparent weight calculations. Clear? When the bob or body moving in the water environment, that is how much? Apparent weight. What is the apparent weight? Actual weight into 1 minus density of the fluid by density of the bob. This is apparent weight. Entire physics. Whenever the body moving in the fluid environment. Clear? So here, W apparent is nothing but mg effective. Mg effective equal to mg into 1 minus density of the fluid by density of the bob. G effective equal to how much? G into 1 minus density of the fluid by density of the ball. Density of the fluid by density of the ball. Understood or not? So weight of the ball in the fluid, when it is in the fluid, when the body is moving in the fluid, actually we need to take when the body motion under gravity, density of the fluid is what? Air. Density of the air is neglected. That is why apparent weight becomes equal to actual weight. Apparent weight becomes equal to actual weight. Understood? Completed. Next write down case 2. Next write down case 2. G effective calculations. G effective calculations. Case 2. Case 2. Now we can place this simple pendulum oscillating in the electric field. Mass of the ball, charge on the mass, charge on the ball plus Q, charge on the ball plus Q. Here it is how much? We need to disturb the system. It would be M. Here to here, angular disturbance. So electric field is acting in this particular direction. Electric field acting in this particular direction. Electric field acting in this direction. Focus here. Electric field is acting. This is E bar, positive charge. When what is the force experienced by the positive charge? This is M, mass M plus Q. Electric field, when it is placed in the uniform electric field, when the particle placed in the uniform electric field, what is the force experienced by the charged particle? Force experienced by the charged particle when it is placed in uniform electric field. This is how much? Force experienced by this electrostatic force. Okay na? F equals to how much? EQ. EQ or QE. Understood? Force experienced by charged particle, electrostatic force. This is how much? Electrostatic force experienced by the charged particle. Electrostatic force experienced by charged particle. When it is placed in uniform electric field, it is acting in the direction of electric field. If it is the positively charged particle, F E bar equals to Q E bar. It is acting in the direction of electric field. Then what you will get, tell me? Weight acting vertically downward direction. Electrostatic force is acting. It is also in the direction of electric field. Understood? Now tell me, what is the net force acting on the ball? Mass of the ball. Here, what is the net force acting on the ball? Mg plus QE. This is the net force acting on the ball. F net. Net force acting on the ball balanced by who? Mg effective. Mg effective equal to F net. Understood? So Mg effective equal to how much is obtained here? Mg plus QE. What is the G effective here? G effective equal to how much? G plus QE by M. This will be G effective QE by M. What is the time period of oscillation? T equal to 2 pi square root of L by G effective. L by G effective. Substitute G effective here. T equals to 2 pi square root of L by G plus QE by M. QE by M. QE by M. L by G plus QE by M. Completed. Next, case 3. Now coming to case 3. Now electric field is acting in horizontal direction. Electric field may act upward direction, downward direction, right side, left side. Okay now, whatever at some angle, whatever the question it is, you are in position to answer. Completed. Now tell me. Now the electric field is acting. Completed.
Yes, sir.
Now electric field is acting. Here, case 3. Electric field is acting. Here to here. This is the bulb. Here to here. We need to disturb it. This would be theta. Electric field is acting in horizontal direction. Electric field is acting in horizontal direction towards right. Electric field, uniform electric field. Entire simple pendulum placed in the uniform electric field. Weight acting vertically downward direction. Weight acting vertically downward direction. Along this direction, what you will get? Electrostatic force in the direction of electric field. In the direction of electric field. In the direction of electric field. Now tell me. So draw this figure. This is the mass M. Charge of the bulb plus Q. Electrostatic force equal to how much? EQ or QE? QE. Understood? Weight acting vertically downward direction. What is the net force acting on this? What is the net force acting on the bulb? Net force acting on the bulb. F net equal to how much? Square root of how much? mg square plus QE square. This is balanced by whom? mg effective. This is balanced by whom? mg effective. Understood? So mg effective can be written as mg effective equal to how much? Square root of, that is F net, mg square plus QE square. So take m square inside. G effective equal to how much? Square root of G square plus QE by m whole square. QE by m whole square. What is the finally time period of oscillation? 2 pi square root of L by square root of G square plus QE by m whole square. QE by m whole square. Are you following? This QE by m whole square. Time period of oscillation when the electric field is what? Horizontal. Electric field is horizontal. Completed. Square root of G square plus QE by m whole square. Completed. Next write off. In this case, next case 4. This part done. case 4, case 4, here to here. This is M. This is M. Electric field makes an angle theta with the horizontal. This is the disturbance, angular disturbance, theta. So here it can make phi. So it can make, it would be inclined. Electric field is inclined. Electric field is inclined. It makes an angle phi with the horizontal. Phi with the horizontal. Understood? Now tell me. Now what you people are getting? Completed. Now, so how to draw this figure? Tell me. M. This would be M. Weight always up. Vertically downward direction. Weight always up. Vertically downward direction. Electrostatic force. F equal to how much? QE. F equal to how much? QE. F equal to how much? QE. So now tell me here. This is how much? 5. 5. This is how much? 90. 90. What is the angle between these two vectors? What is the angle between these two vectors? Understood? So what is the angle between these two? 90 plus 5. So the net force will be like this. This would be net force. Understood? So here this is balanced by mg effective. Mg effective. These two will be balanced. How to calculate F net? How to calculate F net? Chapandi, F net, apply parallelogram law vectors. Apply parallelogram law vectors. Mg square. Mg square plus mg square plus mg square plus qv square. QE square plus this is how much? Minus parallelogram law vectors. 2 times of mg. 2 times of mg into 2 times of mg into qv into. Here how much will be getting? Cos 90 plus 5. Cos 90 plus 5. Understood? Cos 90 plus 5 how much? Completed. This part F net can be written as this is equal to mg effective. That equal to how much? mg effective. mg effective. So g effective equal to how much? G effective can be written as G effective can be written as G effective can be written as square root of G square root of G square plus QE by M whole square. QE by M whole square. Then 2 minus 2 times of here plus G into QE by M. G into QE by M. Then cos 90 plus 5 how much? Minus sin 5. Clear? If it is horizontal, phi equal to how much? 0. Then you will be getting this. You will be getting phi equal to 0. If it is vertically downward, phi equal to minus 90. Clear? Phi equal to how much? Minus 90. Then how much will be getting? Phi equal to how much? Phi equal to how much? 270 also you can substitute. Here, angle should be measured from the positive x-axis in this direction. Phi equal to 270 plus will come. Phi equal to 90 minus will come. Yeah, matching. Clear? Completed? అర్థం కాలేదా ఇది? అర్థమైందా లేదా? మళ్ళా చెప్పాలా? ఇది అర్థం కాలేదా? ఇది ఒక వెక్టారు, ఇది ఒక వెక్టారు. ఈ రెండింటికి రిజల్టెంట్ కనుక్కునే ప్రొసీజర్ ఏంది? పారలెలోగ్రామ్ లా ఆఫ్ వెక్టార్స్. cos 90 plus 5 ప్లేస్ లో minus sin 5 పెట్టడం. క్లియరా? అయిపోయిందా ఇది? If you keep phi equal to completed. ఇప్పుడు మనము g ఎఫెక్టివ్ ఇది ఉంది. g ఎఫెక్టివ్ ఇలా ఉంది. సో ఇప్పుడు మనం ఏం చేయాలంటే డిఫరెంట్ కేసెస్. సో ఇక్కడ నుంచి ఎలా వస్తున్నాయి అనేది ఒకసారి చెక్ చేయండి. ఈ పర్టికులర్ ఈ ఒక్క ఎక్స్ప్రెషన్ చాలు మీకు. సో ఏ క్వశ్చన్ అయినా ఆన్సర్ వస్తుంది. సో ఒకవేళ నువ్వు ఇలా తీసుకున్నావు అనుకో, ఫస్ట్ కేసు ఏంది? సో ఇలా తీసుకుంటే ఇట్లా కానీ ఉందనుకో, దిస్ ఈజ్ ద మాస్ ఆఫ్ ద బాల్. సో ఇక్కడ నీకు నేను ఇప్పుడు ఎలా తీసుకుంటామంటే అప్వర్డ్ తీసుకున్నాం అనుకో, ఎలక్ట్రిక్ ఫీల్డ్ అప్వర్డ్ మనం సాల్వ్ చేయలేదు కదా. ఓకే, అప్వర్డ్ తీసుకుంటే ఏమొస్తుంది చెప్పు? తీటా ఫై ఎంత వస్తుంది చెప్పు? ప్లస్ 90. ఫై ఈక్వల్ టు 90. ఫై ఈక్వల్ టు 90 గా పెడితే ఏమొస్తుందా? a స్క్వేర్ ప్లస్ b స్క్వేర్ మైనస్ 2ab వస్తుంది. క్లియరా? g ఎఫెక్టివ్ ఈక్వల్ టు హౌ మచ్? g ఎఫెక్టివ్ ఈక్వల్ టు హౌ మచ్? g minus QE by M. G minus QE by M. అదే కానీ ఎలక్ట్రిక్ ఫీల్డ్. సో ఇది పైకి. సో అలా కాకుండా సో దీన్ని నువ్వేం చేస్తావు అంటే ఇయర్ టు ఇయర్, దిస్ ఈస్ ద బాంబ్, దిస్ ఈస్ M. తీటా లెఫ్ట్ వేసినా నీకు అదే వస్తుంది కదా. లెఫ్ట్ అంటే 180. సో డౌన్వర్డ్ అంటే ఏంది? ఒకవేళ నువ్వు డౌన్వర్డ్ తీసుకుంటే ఏం చెప్పు? డౌన్వర్డ్ తీసుకుంటే ఇయర్ టు ఇయర్, దిస్ వుడ్ బి హౌ మచ్? 5 ఈక్వల్ టు హౌ మచ్? 270. క్లియర్? 270 పాజిటివ్ డైరెక్షన్ ఆఫ్. అప్పుడు నువ్వు ఎట్లా తీసుకున్నా ఇట్లా 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 ఏ డైరెక్షన్ లాగా నీకు ఆన్సర్ వస్తుంది. ఎలక్ట్రిక్ ఫీల్డ్ రైట్, పైకి, సైడ్ కి, ఇటు 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 ఎటైనా 360 డిగ్రీస్ లో ఎట్ ఇచ్చినా ఆన్సర్ వస్తుంది. క్లియరా? ఆర్ ఇట్ క్లియర్ ఆర్ నాట్? సో 5 ఈక్వల్ టు 270 అంటే మైనస్ వస్తుంది. g ఎఫెక్టివ్ ఎంత? g ఎఫెక్టివ్ ఎంత? g ప్లస్ qb బై m. g ప్లస్ qb బై m. ఆర్ యు ఫాలోయింగ్ ఆర్ నాట్? దిస్ ఇస్ ద ఎలక్ట్రిక్ ఫీల్డ్. when you place it in the electric field. Now coming to case 5. Next one, apparent weight of the body in the lift. Apparent weight of the body in the lift. Apparent weight calculations in the lift. Again that. So parallelly laws of motion content need to be covered. The laws of motion lo kuda ilane untayi. Clear? Completed. ఓకే, సో ఒకవేళ నువ్వు ఇట్లా తీసుకుంటే see this electric field. If you take electric field, so towards left తీసుకుంటే phi ఎంత ఇది? 180. Towards left తీసుకుంటే phi ఏమైంది? So this is how much? Phi equal to 180. 180 sin for 0. What is the g effective in this case? Square root of g square plus QE by M whole square. Understood? Completed. This part done.
No, sir.
Next,
No,
case
sir.
5.
Sir, sir, sir.
ఇది అవ్వలేదా?
No, sir.
ఏం రాస్తున్నారు మీరు ఇందాక నుంచి?
నేను ఉంటా అన్నా సార్ మర్చిపోయినా అడిగాను.
దిస్ ఈస్ కేస్ 5. నెక్స్ట్ ఏంది కేస్ 5? కేస్ 5. apparent weight calculations. Apparent weight calculations in the lift. When the lift is moving upward, what is the apparent weight? Lift is moving downwards. Now we need to place. After that we need to place simple pendulum in the lift. Projectile motion in the lift. G effective calculations in the lift. G effective calculations moving upward. G effective is equal to how much? G plus A. Moving downward. G effective is equal to how much? G minus A. Completed. How to calculate apparent weight? W apparent weight calculations in the lift. Apparent weight calculations in the lift. అయిపోయింది. Apparent weight calculations in the lift. Case, which case? Case 5. So take lift. This is the lift. Here to here. So lift is moving upward or downward?
Upwards.
Here to here. This is the mass M. Here to here. This should be how much? M. Theta. Lift is moving upward. Acceleration of the lift. This is A is the acceleration of the lift. This is acceleration of the lift. Acceleration of the lift. Acceleration of the lift. Weight acting. So in this case, what you will get as name? Weight acting. Weight acting vertically downward direction. Inertia force always at opposite to the direction of motion. అప్పుడు ఏమొస్తుంది నీకు? అప్పుడు ఏమొస్తుంది? మాస్ ఇంటూ యాక్సిలరేషన్ ఆపోజిట్ టు ద డైరెక్షన్ ఆఫ్ యాక్సిలరేషన్. నౌ టెల్ మీ వాట్ ఈస్ ద నెట్ ఫోర్స్ యాక్టింగ్ ఆన్ దిస్? M. So we can take acceleration how much? This would be acceleration A. Acceleration A. M into how much? G plus A. M into how much? G plus A. Understood? Mg effective. This is the F net. Net force acting on this. This net force acting on this balanced by whom? Mg effective. Mg effective. Mg effective. What is the Mg effective here? Tell me. Mg effective equal to how much? M into G plus A. M gets cancelled out. G effective. Lift is moving upwards. Lift is moving upwards. Lift is moving. Lift is moving upwards. When lift is moving upwards, G effective will come. G effective equal to how much? G plus A. G effective equal to how much? G plus A. G effective equal to how much? G plus A. What is the time period of oscillation of simple pendulum? 2 pi square root of L by G plus A. G effective. G effective. G effective. 2 pi square root of L by G plus A. Okay. Time period decreases or increases. time period decreases or increases? Time period decreases. Loss in time. Loss in time. Loss in time. Next, when lift is moving downwards. Lift is moving downwards. When lift is moving downwards. Weight acting downward. Here, lift is moving downwards. When lift is moving downwards, here to here, this is the acceleration. Acceleration of the lift. Here. So here what we will get? Minus. Here minus. Here minus. Gain in time. Gain in time. Gain in time. Here what you will get? Inertia force will be acting opposite to the direction of motion. M into A. Inertia force always act opposite to the direction of motion. So the lift is moving downwards. Acceleration of the lift is downwards. Inertia force is acting upward. What is the F net? Tell me. M into G minus A. F net is balanced by mg effective. Mg effective equal to M into G minus A. G effective equal to G minus A. T equal to 2 pi square root of L by G minus A. So here gain in time. Gain in time.
Acceleration direction.
So this direction acceleration must be. Here it is how much? When lift is moving downwards. Lift is moving downwards. Clear up? Lift is moving downwards. Lift is moving downwards. Completed. This is case 6. Now case 7. Completed. Next item, pendulum in the accelerating vehicle. Pendulum in the accelerating vehicle. Pendulum in accelerating vehicle. Case 7. Pendulum in the accelerating vehicle. Focus here. Case 7. Case 7. Write down. Pendulum in the accelerating vehicle. Pendulum in the accelerating vehicle. Accelerating vehicle. Pendulum in the accelerating vehicle. So take one vehicle. It's a truck. It's a truck. Here to here. It's a truck. It is accelerating. It's a truck. Truck. Understood? The acceleration of the truck is The acceleration of the truck is, focus here. So pendulum is oscillating. This is the pendulum. Pendulum is oscillating. Pendulum is oscillating. Clear? We disturb the system. Understood? So acceleration of the truck along this particular direction. This could be acceleration of the truck along this particular direction. Clear? Now tell me. So what is the bob? Here to here. Here weight is acting. Weight is acting vertically downward direction. So acceleration along this direction. Inertia force will be acting opposite to this. Opposite to this. Understood? Now tell me. Here. This would be mg is acting downward direction. Mg will be acting downward direction. It is m. Understood? Here acceleration along this direction. Inertia force always at opposite to this. Mass into acceleration. అర్థమవుతుందా? దాని తర్వాత what is the net force acting on this? What is the net force acting on this? Square root of mg square plus ma square. Mg square plus ma square. Now, so this is balanced by who? Mg effective. Mg effective. Mg effective. These two are balanced. These two are balanced. Mg effective equal to how much? Mg effective equal to how much? Mg effective equal to how much? F net square root of mg square plus ma square. Mg square plus ma square. Or m square taken out. G effective can be written as G square plus a square. This is how much? G square plus a square. G square plus a square. So what is the time period of oscillation? Time period of oscillation equal to how much? 2 pi square root of L by square root of G square plus a square. L by square root of G square plus a square. This is the time period of oscillation of simple pendulum in acceleration truck. Accelerating truck. Next. Next item. The car is in the circular motion. Car is moving on the circular road. Pendulum is oscillating in the car. Pendulum oscillating in the car. Clear? Pendulum oscillating in the car. Here S8. This is center of circular motion. Center of circular motion. Car on the circular road. Car is moving on the circular road. Here, car is moving on the circular road. Circular road. Here to here. So here pendulum is oscillating. Pendulum is oscillating in the car. Pendulum is oscillating in the car. Here we need to see from the top. See from the top. here to here. This is the pendulum oscillating in the car. Are you following? Huh? Pendulum oscillating in the car. So we need to see from the top view. Clear? So ఇప్పుడు మనకి this part completed. What are the forces are acting on the car? Tell me. Radial acceleration. Radial acceleration. Radial acceleration. Radial acceleration. So called centripetal acceleration. Always act towards the center of circular motion. This is called radial acceleration. Radial acceleration. Radial acceleration. Radial acceleration. So called centripetal acceleration. Centripetal. Centripetal acceleration. Centripetal acceleration. Radial acceleration equal to how much? Radial acceleration equal to how much? What is the radial acceleration equal to how much? Omega square. What is the radius of curvature of the road? Omega square of V equal to how much? So if it is moving, this is omega. This would be how much? This would be how much? V equal to R omega. V equal to R omega. So if you substitute that part, V square by R will come. That is the radial acceleration. Inertia force in the circular motion is what? Centrifugal force. Centrifugal force always act opposite to the direction of centripetal acceleration, so called radial acceleration. So here, what is the centrifugal force? Always act away from the center of circular motion. Center of the circular motion. మీకు తెలుసా తెలీదా? రేడియల్ యాక్సలరేషన్ అంటే సెంట్రిపెటల్ యాక్సలరేషన్ అంటారు. రేడియల్ యాక్సలరేషన్ ఎప్పుడు కూడా ఆల్వేస్ యాక్ట్ టువర్డ్ ద సెంటర్ ఆఫ్ సర్క్యులర్ మోషన్. రేడియల్ యాక్సలరేషన్ ఎప్పుడు కూడా సెంటర్ ఆఫ్ సర్క్యులర్ మోషన్ ఉంటుంది. అర్థమైందా? సో ఇక్కడ సెంట్రిఫ్యూగల్ ఫోర్స్ ఏదైతే ఉందో, సెంట్రిఫ్యూగల్ ఫోర్స్ అనేది ఈ రేడియల్ యాక్సలరేషన్ కి ఆపోజిట్ డైరెక్షన్ లో ఉంటుంది. ఇప్పుడు దాకా మనం ఏం తీసుకున్నామో, ఇనర్షియా ఫోర్స్ ని యాక్సలరేషన్ కి ఆపోజిట్ డైరెక్షన్ లో తీసుకున్నాము. సర్క్యులర్ మోషన్ లో ఇనర్షియా ఫోర్స్ అంటే ఏంటంటే సెంట్రిఫ్యూగల్ ఫోర్స్ అన్నమాట. ఈ రేడియల్ యాక్సలరేషన్ కి ఆపోజిట్ డైరెక్షన్ లో ఇనర్షియా ఫోర్స్ రిప్రజెంట్ చేస్తే ఆ ఇనర్షియా ఫోర్స్ ని ఏమంటామో సెంట్రిఫ్యూగల్ ఫోర్స్ అంటాము. సెంట్రిఫ్యూగల్ ఫోర్స్ అంటే ఇక్కడ మనకి ఏం అర్థం కావాలి? రేడియల్ యాక్సలరేషన్ సో కాల్డ్ సెంట్రిపెటల్ యాక్సలరేషన్ ఆల్వేస్ యాక్ట్ టువర్డ్ ద సెంటర్ ఆఫ్ సర్క్యులర్ మోషన్. Centrifugal force always act opposite to the direction of radial acceleration means what? It always act away from the center of circular motion. అర్థమైందా? రేడియల్ యాక్సలరేషన్ ఎప్పుడు కూడా టువర్డ్స్ ద సెంటర్ ఆఫ్ సర్క్యులర్ మోషన్ ఉంటే, సెంట్రిఫ్యూగల్ ఫోర్స్ ఎప్పుడు కూడా అవే ఫ్రమ్ ద సెంటర్ ఆఫ్ సర్క్యులర్ మోషన్ ఉంటుంది. అర్థమైందా? సో ఇప్పుడు నీకు రేడియల్ యాక్సలరేషన్ అంటే ఏంటి? ఇక్కడ ఎఫ్సి ఏం రాయొచ్చు? m ఇంటూ ఒమేగా స్క్వేర్ r రాయచ్చా? ఇది వద్దనుకుంటే mv స్క్వేర్ బై r రాయచ్చా? అది క్లియర్? v ఈక్వల్ టు ఒమేగా, v ఈక్వల్ టు ఒమేగా సబ్స్టిట్యూట్ చేస్తే నీకు ఇది వస్తుంది. క్లియరా? సో నౌ వి నీడ్ టు క్యాలిక్యులేట్ g ఎఫెక్టివ్. g ఎఫెక్టివ్ మాస్ ఆఫ్ ద బాల్, మాస్ ఆఫ్ ద బాల్. వెయిట్ ఆల్వేస్ యాక్ట్, వెయిట్ ఆల్వేస్ యాక్ట్ vertically downward direction. సో ఇప్పుడు నీకు రేడియల్ యాక్సలరేషన్ ఏ డైరెక్షన్ లో ఉంది? ఈ డైరెక్షన్ లో ఉందా? రేడియల్ యాక్సలరేషన్ ఈ డైరెక్షన్ లో ఉందా? దీనికి ఆపోజిట్ డైరెక్షన్ ఏముంటది? దిస్ ఈజ్ వాట్? సెంట్రిఫ్యూగల్ ఫోర్స్ mv square by r. mv square by r. What is the F net is acting on this? What is the F net? F net acting on the bomb. What is the F net? చెప్పండి. F net This F net is balanced by whom? mg effective. mg effective. అర్థమవుతుందా? This F net is balanced by whom? mg effective. Clear? So mg effective equal to how much? mg effective equal to how much? ఇక్కడ F net equal to how much? F net equal to how much? చెప్పండి. mg effective here what you will get? mg square plus how much? mv square by r whole square. mv square by r whole square. That equal to how much? mg effective. That equal to how much? mg effective. Okay na? So mm gets cancelled out. Finally g effective can be written as ఏం రాయొచ్చు చెప్పండి? g square plus v square by r whole square. All are previous year questions. ఇది కూడా one of the previous year question. అర్థమవుతుందా? ఈ కేసెస్ అన్నీ కూడా ప్రీవియస్ ఇయర్ క్వశ్చన్స్ ఎప్పుడో ఒకప్పుడు వచ్చినాయి. ఓకేనా? g effective equal to how much? Square root of g square plus v square by r whole square. So what is the time period of oscillation in this case? 2 pi square root of L by g effective. L by g effective how much will come? g square plus v square by r whole square. v square by r whole square. v square bar is the radial acceleration. So how many accelerations will come for say circular motion? What are the accelerations? Radial acceleration and tangential acceleration. This part completed. Right on up to here. Next case.